All right, if you are watching this, then you know that there is an extra points assignment for basically redoing all of the, I say all of the, like there's that many of them, the three lab assignments for this semester, but using R to do it. So throughout the semester, we've sort of daisy chained together Google Sheets, Microsoft Excel, this website, that website, some other website. Whenever you become more, whenever you grow along in your statistical journey, it's nice to eventually be able to do all these things on one platform instead of a bunch of other ones. And R is one of the best skills you can pick up if you ever bump shoulders with statistics, because R is basically the lingua franca of the statistical world, which basically just means it's the language that everyone speaks. So in private industry, like in Silicon Valley and other businesses around the world that does any kind of data analytics, a lot of them use R. Academia, when people do research, they use R much of the time. In government sector jobs, they use R. It's a very common language, so it's worthwhile to become acquainted with it, and I'm going to make it as easy as I can for you. Um, I don't go over how to install it. I posted a link in the assignment on how to do that. I'm just going to focus on once you have R up and running, what to do from there. So you're going to see there's 4 windows in RStudio. RStudio basically takes R itself, the program, and just makes a slightly more user-friendly interface for it. And this interface has 4 windows. In the top left, you've got the coding window, where you've got a lined sheet where you can write in your code. You can write 2 plus 2. And if I execute that code, and if I highlight it, and I hit Command Return on my Mac, it's a different button combination on a PC. Let me go see what that is. Let's see. What is it? I had to look it up because I don't use R on a PC. Control Enter. Well, if you highlight some text and you hit Control Return, the result of running that code will appear at the bottom of the console. So I could write 2 star 2, which is 2 times 2. You see it comes down here and it says that equals 4. And this code, if I want to come back later because I forgot what 2 plus 2 or 2 times 2 is, I can save it, hit Command S, and write R extra points assignment, save that to my desktop. If I go to my desktop, there's now a file called R extra points assignment.r, and you can send this to someone. Like, you could send this to me, and when it opens, it'll have the script that you wrote in the scripting window right here, and I can say, 2 plus 2 does equal 4. Amazing. Yeah. These other windows, so this one tells you all of the values and data, etc., that are currently active. It's empty right now. You'll see some stuff appear once we actually get started. And then down here, by default, the bottom right is where your plots will appear if you tell R to make some plots. One very useful thing, if you're going to do any kind of programming, is comments. Whenever you write a comment, most programming languages, there's some sort of symbol or a series of symbols which basically says, hey, anything past this point, don't read it, don't execute it. This is more a note to self for the human. In R, that is the hashtag symbol. I'm going to put hashtag lab. I'm in the wrong thing. The hashtag lab1. So that way when I come back and look at my code, I know that everything under here is from lab 1, and then later I'll write lab 2, and I'll know everything under here is for lab 2. It makes it easier to read. And in general, you want to get into the habit of leaving comments so it's easier for people to come later, and or for yourself to come later. A lot of people can't read their own code when they come back later. So it's just a good habit to have. So for lab 1, you had to do the tomato meter scores. I'm going to cheat a little bit. I have the completed script in a separate tab, and I'm sure you don't want to watch me copy data manually, but you'd want to take your tomato meter scores. So I just took a variable. I decided to call it TTS, Tarantino tomato meter scores, and I set equal to, and then I filled up. This is called a concatenation. C open parentheses, and then you enter your data in between the parentheses. You separate each data point with a comma. So if you, and see, I've got a comment here saying like this is Tarantino tomato meter scores. If I double click and highlight this and I execute it, command return, now the system has saved. There's a variable called TTS, and it's equal to this sequence of 10 numbers, 85, 74, so on and so forth. So if I just type TTS and I execute TTS by itself, it just says, yo, that's 85, 74, so on and so forth. I mean, we already said that. But once it's saved in the system, then you can do things like, if you want to see a histogram of your scores, you can type HIST, that's short for histogram, open parentheses, and put the name that you gave to your data set, TTS. Highlight that and run it. And look, R makes a little histogram for you, and it's actually easier, I think, than Google Sheets. And, it doesn't matter what you call the data set. You could have wrote TTS lowercase equals C, whatever. Now if I wrote hist lowercase TTS, it'd be a different histogram. It's completely arbitrary what you call it. As long as you use it, it's case sensitive. As long as you're using the correct, that's what you typed, then it should be fine. And then you needed the mean, median. We're going to forget about mode, range, and standard deviation. That's all very easy. Once you have your data saved under a variable name like TTS, you can just type mean, open parentheses, TTS, close parentheses. You run that, and it'll say down here, that's 84. Mean of this data set right here is 84. Median, and in parentheses put TTS, it's 86. Range, if you type range, it'll actually give you the lowest and the highest, the minimum and the maximum, which is 65 and 92. That's not exactly what we want, so you can instead say max, in parentheses, TTS, and then outside of the parentheses you can say minus, and then min, in parentheses, TTS. So max TTS minus min TTS. If you run that, 27 gets printed in the console, so that is the range. And then if you want the SD, you just write SD in parentheses TTS. It says it right down here. And that's everything you need for lab number 1. You put your tomato meter scores in here. You delete the Tarantino ones. You put the first one, comma, the second one, comma, the third one, comma, and then when I post this, I'm going to post this script that I'm working on right now. You can download it and open it in R. And as long as you replace these numbers with your numbers, all of these should run just fine, but it'll be your mean and your median and your standard deviation instead of mine. So that's how you do lab 1. Let me put a comment for lab 3. Now for lab 2, we did heights and weights of players, and I have those saved already in the completed one, so I'm just going to put that here. So I'm creating a new variable called heights. I'm setting it to be equal to, and I put C, concatenate, and in between parentheses, I've got my data numbers separated by commas. The first player is 69 inches tall, comma. Second player is 75 inches tall, comma, so on and so forth. Weights, same thing, but with weight. And easy peasy, if you want to do a correlation analysis, you do core, C-O-R, dot test, open parentheses, and then you put the first variable that you want to do a correlation analysis on, heights, comma, and then you put the second variable you want to have, weights. Core.test, open parentheses, heights, comma, weights. That says I want to do a correlational test on heights and weights. You highlight that and you run it. Yeah, I didn't actually run these. I just pasted them in, so they're not saved. They're not active. So if I double-click heights, highlight it, and run it, now heights is actually saved, and it's a usable variable. Do the same for weights. See, now they're actually active. So now this should work. There we go. If you zoom in here, it says Pearson's product moment correlation. T equals 2.8115, degrees of freedom equals 10, p-value equals 0.01843. It's got some additional information in here, but the real important one is core at the bottom, and underneath that it has the estimated correlation between height and weight. And just like that, you're done with lab number 2. It's just a correlation between two variables. I've got the variables saved as concatenations. Last but not least is lab number 3. If you saw my other video, you know that I misplaced my own data of Radiohead versus Green Day. So I just, like any good, sane person, just stole another student's who already did lab 3. She had the number of unique words for 10 Christina Aguilera songs. So I'm going to create a variable called Aguilera equals, and then I've concatenated these numbers together to represent that data. And then the student, she probably put 10, maybe I miscopied it. I think there's actually 9 in here. But I put the Britney Spears number of unique words in there. So I'm going to run both of these. And you can highlight both lines together and run them both. You don't have to do it one at a time. And then for lab 3, we did a t-test, independent samples t-test on this data. So in R, you put t.test, open parentheses, and then you put the name of the first variable you want to do your t-test on, Aguilera. I'll do autofill on that, comma, and then you put the second variable, Spears. So t-test, and in parentheses, your first variable, comma, your second variable. If you execute that line of code, the default in R is to do Welch's two sample t-test, independent samples t-test. I talk about Welch's t-test briefly in the textbook. Basically, it's a modified version of the t-test that corrects for the fact that the two distributions that your sample means are coming from don't necessarily have equal variances. That is to say, equal standard deviations. They're not equally spread out. That's one of the assumptions of the test. And if the assumption is broken, then your test is less trustworthy. So Welch's t-test kind of makes some adjustments to make up for that. So if you leave the default on, you get a t-value equal to 2.16, degrees of freedom. What is this? Degrees of freedom 10.319. If you've been reading very carefully in the textbook, you know that this must not make any sense to have a non-integer as the degrees of freedom. Well, don't worry, that's part of Welch's t-test. It messes with the degrees of freedom to adjust for unequal variances. And then you got the p-value is close to 0.05, but is actually slightly above 0.05, so this would not be considered statistically significant. This is all the information you really need to say what the results of the t-test are. It also gives you the mean of X and the mean of Y. So Christina Aguilera had 134.5 words, unique words on average. Britney Spears had 94.1. If you also want the standard deviations, you could write SD Aguilera, that was 57.05, and SD Spears, my computer messed me up. You have to spell Spears right. If you put Spears with 2 E's like I just did, the computer is going to be like, I don't know what you're talking about, Spears with 2 E's. You've never told me anything about a Spears with 2 E's. Obviously, I'm talking about Spears with 1 E, but, you know, computers aren't humans. They don't know what you mean. They only can read what exactly you said. So anyway, you can see the standard deviations are very different. Christina Aguilera's has a standard deviation of 57, and Britney Spears has a standard deviation of 15.48. Very different variances. So if you were to do a normal t-test without the Welch's correction, you would get a statistically significant result. This isn't part of the assignment. You don't have to do this, but just to turn off Welch's t-test, you do var.equal and put false. Oh wait, no, var.equal equals true. There we go. So this is a normal two-sample t-test on Christina Aguilera versus Britney Spears, and it is statistically significant. Degrees of freedom is 18 now instead of 10.31, and the p-value is 0.04, which is less than 0.05, so it's statistically significant. You don't have to do both versions of the tests, but if you do see a discrepancy, that's why there's a discrepancy. And that's really everything you would need to get the 25 bonus points. Lab 1, you replace this data with your own data and make sure if I run this code that it'll be the correct output for your data. Lab 2, put your heights for your players and their weights saved into the system, and then if you leave this core.test and then heights, comma, weights in parentheses, if you leave that like that, it should work, but like it'll be your results instead of my results. Same thing as down here. You replace this with your recording artist. You could even, like if you did Kanye West versus Taylor Swift, you could even leave the first one, if it's Kanye West's data, you could replace the data but leave it named Christina Aguilera, just because you don't want to have to go change Aguilera. I would have to change here, 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 and here for all this data to work correctly. You could just leave it as Aguilera, but no, mentally, I put Kanye West's numbers in this variable. And then for Britney Spears, you put Taylor Swift's. And you could leave it as Spears if you want to, just so that all the times that Aguilera and Spears are used as variable names, they still work. Because if you change this to Kanye, then you have to change this to Kanye and this to Kanye. You know, you don't want to necessarily have to do that. So just change the data, and if I make it to where if I run your tests, I can see that you get the same results as on your homework. And that's basically it. It might seem like a lot to take in, but I think it is really worthwhile to dip your toe into the world of R, and that's why I'm giving 25 bonus points if you do it. So if you have any questions, shoot me an email, and until next time, you have a good one.